All right, let's start 16.3 here. Part 1, some proofs. All right, looking at the figure, okay, get an idea of PQR, STR. Okay, that's what we want to prove. Those two triangles are congruent. So we need one of the rules: side angle side, side side side, etc. Okay, so let's look at our statement. So given, we have PQ and ST. Okay, given. So let's mark it, PQ and ST. Then we also have QR, TR, that's given. Okay, so QR and TR. So that's also given. And the third given piece is R is the midpoint of PS. So that means this side is congruent to this side. Okay. So this was given. I guess I jumped ahead knowing that there was a midpoint. Those two are congruent. And that's what was stated here. So PR is congruent to SR because of the midpoint. Definition of midpoint. So now our last statement's already there. Triangle PQR, STR are congruent because of side, side, side. So I'll just do S, S, S. Okay, let's check out the next one. There's our figure. It says that SQ bisects angle RQT and angle RST. Okay, so let's write down we'll say given. Now we know if that's a bisector, we know that this angle is congruent to this angle and this angle would be congruent to that angle because it's a bisector of both of those, it said, both of those. So that's probably the next step here on the proof. Angle RQS and TQS, okay, because of the bisector. Okay. And the other one, RSQ, TSQ, same thing, definition of the bisector. All right, so now what do we have? QS congruent to QS. Oh, it's congruent to itself. Right, because it's shared by those both triangles. So what property is that? Something congruent to itself. That would be the, what, reflexive property? Okay. Now the two triangles are congruent because we have two angles and a side in between. So angle, side, angle. All right, let's see next. Triangle LMP and MNP, it says, are right triangles. That is given. And ML is congruent to MN. ML and MN, that is also given. Now the next statement says MP is congruent to itself. Well, we just did one of those. That was reflexive. And now the two triangles are congruent because, well, if it's a right angle, I'm first thinking hypotenuse leg, but then I have to make sure that I have the hypotenuse and one of the sides. And I do have the hypotenuse and a side. Okay, so this one would actually be hypotenuse leg. All right. Let's go to page 8. Let me double check here. And on yours are part 2. So I'm going to do I'll do half of these first ones, and then we're going to go to 16.4 and do half of those. Okay. We'll just get you started on these. So I did those 3. I'll do 4, and then you can do the next 4 or next 5. Okay, let's see. This is page 8, number 4. So JK is parallel to LM, and JL is parallel to KM, so that's given. So now I'm going to go mark those parallel lines, JK and LM, and then JL with KM. All right, now we know which ones are parallel. The next statement says JKL is congruent to MLK. So this one is congruent to this one. Well, those look like alternate interior angles to me. So that would be the rule. Alternate interior angles are congruent. So I just use the symbols. Alternate interior angles congruent. Now JLK, it says is congruent, so we'll mark that with 2. JLK with MKL. I think that's the same rule. Those are alternate interior angles. If those two are parallel, there's the transversal, alternate interior, so the same reason for those as well. And then KL, it says, and LK. KL and LK, they're written differently, probably because of the way the triangle needs to be named. So if you name it KJL, it'd have to be named MLK. So that, or JKL, MLK. So that's why those are written differently, because it would be named in that order from the two triangles. But it's the same rule, reflexive. All right, and then JKL, the triangle, and MLK, the triangle, are congruent because we have two angles, this side, congruent to itself. So that would be what? Angle, side, angle? Because the side is in between the two angles. Okay, so I'm going to let you do the rest.